So we're going to solve these, and we don't have to use models on these, so as it turns out, we can use the T model. So when we see this problem like these, we can create our T radical. Now remember, the first thing we should do is, if we can simplify it, we would. But radical, we can't. So the next thing we'd want to do is get the 6a by itself. So it's kind of like we're trying to get 6a plus 0, not minus 4. So how do I get rid of that minus 4 radical? I would end up adding 4. But if I do it to one side, I must do it to the other side to maintain equality. So I got 6a equals negative 16 plus 4 is negative 12. And the plus 0 there is just the additive identity, so we don't need that garbage. Next thing we would do is, we got 6 times a right there. So I'm going to use the inverse operation of division on both sides. And what I want is a 1a, not a 6a. So how do I change a 6a to 1a? Yeah. Bam, you can divide by 6, but on both sides. So 6 divided by 6 is 1. Negative 12 divided by 6 is negative 2. And of course we'll make that a phantom 1. There's our answer. Actually, this one I'm going to rewrite it so that we don't have to look at that as n/7. I'm going to make it 7 equals 6 minus n over 7. Because you should see it like this more often than not. So solving at these, we got 7 equals 6 minus n over 7. So again, it's the idea right here that we want is to get this negative n over 7 all by itself. So we don't want that 6 there. How do we get rid of it? Yeah, we're going to minus 6 to make it a 0. So that becomes a 0 pair now, so it cancels away. And we got 7 minus 6, which is a Juan. Now to solve for n, this is n divided by 7, so to undo it we can use multiplication of 7. But if I do it to one side, I got to do it to both sides. So now these 7's cancel, and I got negative n equals 7. So we got 7 equals negative n, but I don't want a negative n. What I would like is a positive n, so what I will do is I will take the opposite of each. The opposite of negative n is n, and the opposite of 7 is negative 7. There we go. Negative 10 equals negative 10 minus 3x. So again, using our T method, radical. We don't want that negative 10 there, but we can keep the negative 3x. So how do I get rid of that negative 10, which is combined with the negative 3x? We need to add it. Very good. We need it to become a 0. So I will add 10 to both sides. And this does 0 out. Comes a 0 pair. So I got negative 3x equals negative 10 plus 10 is also 0. Now, a lot of people look at this and they wonder what the heck is going on. Well, 0 is a number. It can equal 0. That's okay. The question is, how do we get rid of that negative 3? Because remember, the idea is to get a 1x, not a negative 3x. Yeah, we'll divide by negative 3 on both sides. Why do we divide? Because that's negative 3 times x. Again, we're using the inverse operation there so that we have, we can cancel out the multiplication with the division there, okay? So we got 1x equals 0 divided by negative 3. Some of you guys would say negative 3. But the best thing to do is to punch this into a calculator, and when I do, I get 0. Now naturally we don't need the 1 there to make it a phantom 1. And our answer is x equals 0. Alright, thank you for sharing that with us.
I haven't shared it yet.
But you will, thank you. That was an advanced thing.
Okay, so you got that. And then, since you had this negative 10, you added 10 to this side. So I'm saying if you have this negative 3, you add 3 to this side to get x. And then it would be 3.
I was wrong.
Alright. Alright, so it sounds like your question is, why did we not add 3?
Yeah.
Well, here's the thing is, so let's look at the work on this thing. After we add the 10, that's great, but if I say I'm going to add 3 right here, now you're saying that we're combining like terms, unlike terms rather. We can't say we got 3x plus 3 and then get rid of the negative 3. Because they are not like terms. Yeah, some are turtles, some are fish, right? Alright, these next few problems are just a little bit of review from the last unit. So if we wanted to simplify at these, right, this is like saying that we got 3 sets of 2x and 1. So if I had 3 sets of 2x, that would give me 6 x's. And then if I had 3 sets of 1, then I would have a positive 3 radicale. And this would be fully simplified for us. So if we're reviewing this right now, naturally what will come next in the equations is some distribution. Okay? B, negative 2 sets of 3x and 2. Well, if I had negative 2, and by the way, this distribution is just multiplication like we went over in the last unit. This is really negative 2 times 3x. Well, that would give us negative 6x. And then negative 2 times a positive 2 would become a negative 4. So this would be the simplified form there. Alright, so we got negative 4 times 2x minus 3. So negative 4 times the 2x would give us a negative 8x. Now this next one is considered negative 4 times negative 3, which would be plus 12. So we'll be using this distribution stuff in a lot of the problems that you're going to see on the homework and then, of course, on the classwork. Alright, number 5. We got 2 groups of x plus 1, and that should equal negative 8. So once again, we'll use distribution radical. So 2 times x is 2x, and then 2 times 1 is a positive 2. This should equal negative 8 radical. So now it looks like one of the equations that we're used to seeing, and that's great. So we need to subtract 2 from both sides to solve at these. Now here's some of the problems we've seen in the past. Some people say, well, this is 6. Some people say it's negative 6. Some people say perhaps that it is 10. Well, that's close. It's really negative 10. And this is where calculators become pretty important, since you guys can use calculators now. Is just in your calculator punch in negative 8 minus 2, and then it will give you the answer, okay? But I'm just pointing out that this is a very common mistake for people to just say 8 minus 2, bam, is 6. Well,
then what will you do?
now I got negative 8 minus 2, which was negative 10. This became a 0 pair radical, and we're just left with this 2x. So that's 2 times x. So once again, to undo the multiplication, we're going to have to divide both sides by 2. And we end up with x equals negative 5. Bam. I'm kind of worried. It looks like some of you guys aren't really paying attention to this like you should. Remember, if you don't understand this unit, just know that the rest of 7th grade you may struggle very, very, very badly with. Unless you don't care, then you'll just fail anyways.
Badly?
So it is crucial that you guys know how to do this stuff, and if you have questions, ask. But if you're not going to pay attention, then that's kind of on you.
You're like talking to a certain.
Oh, I already know the answer from yesterday.
It's okay, do it again.
Okay, it's actually Galani.
No talking while he does it, please.
So first you make the T thing, upside down T, and it equals 6, so that's important, I guess. So first you have to do is distribute, so 3 times x equals negative 3 times x equals negative 3x, and then since it's a negative times a negative, it's going to be a positive, so it's plus 12. 3 times 4 equals 12. And then, so, negative, I'm trying to remember, it left my head. Dude, okay, so, if you, So I think you want to do it with the 12 because you want x by itself. So you need so to get rid of plus 12, it's negative 12. And you got, since you did it to this, you have to do it to this side too. And then, so 6 minus 12 equals negative 6. So, and then, now, yeah. And then, negative 3x. So, it left my mind. I know this. I did it last night. So negative 6, negative 3. So you want to get x by itself. So you divide it out or something out to get x by itself. So maybe subtract. Yeah, divide it out. Negative 3. No. Yeah, negative 3. And I think that gets x by itself. I do this problem way different. I just did it for... I usually do it in my head. And
Have to do the same thing.
so, I'm not finished. Here, can I just erase all this fast and redo it my own way?
I'll just finish.
I don't really know how to finish this way. This way. I know a different way.
Divide it by
Well,
6.
let's try it some other time.
I have to divide it by 6, I guess.
Yeah, okay, that's good. Actually, well, yeah, right. We got that negative 6, and then we would divide that by negative 3 as well, and that would give us 2 right here. Now, he mentioned there that we got that negative 3x, and then we're going to divide that by negative 3. Why do we do that? Yeah, do we get x alone? By the way, what is negative 3 divided by negative 3 right here? It's 1, right? And of course, we could show that phantom 1 right there, but it's not necessary that we do. So that is why we want to divide the negative 3x by negative 3 so that we can get the coefficient of x to be a 1. Good luck.
Okay. It equals negative 12. And so you go... And so... we need to do... you put... Yeah, 0. Okay. So negative 3 times 5 is negative 15. X minus negative 3 times negative 1 is 3. So you just minus 3, I think. Right? Do you minus 3 or do you add 3?
What do you think?
What? I'm asking if you minus or add 3.
Are you saying it right here?
Yeah, right there.
Alright, well that's negative 3 times negative 1, right?
Yeah, so it would be 3, but there's a minus sign, so, but then it would equal
That
plus.
becomes a positive 3, so we'll just make that a plus.
Okay. And so then you don't want that plus 3, so then you minus 3 from here, and that's negative 12, negative 15, and then you go, it's negative 15 times x, so then you want to divide, because it's multiplying, right? Yeah, and then you divide by negative 15. And then I'm pretty sure that you get 1. But I think that's right.
Alright, excellent work. It is 1, by the way, so that's good. Joy. So what she did is she took this plus 3 and then she subtracted 3 right there. Again, it's just not shown in the word. But we could show it like that, yeah. And then right there, we could have divided by negative 15, which would have been this step. So let's look at this again. First thing I want to do is to distribute this negative 4. Alright, so I'm going to take that negative 4 and distribute it into the parentheses, which again is just multiplication, so negative 4 times 3 is negative 12. Negative 4 times negative 2m becomes a positive 8m right there. And this should equal negative 12. So I want those 8m's to be alone. So what I will do is get rid of that negative 12 because I don't want those with the 8m. They're not like terms, so we can't combine them anyways. This negative 12 with the 8m right there. Okay. So to get rid of that negative 12, I would have to add 12. Again, the idea is to make that a 0 so that I'm just left with the 8m. But if I do it to one side, I should do it to the other side as well. So I got 8 times m equals 0. Finally, to solve this thing, we would divide both sides by 8. And 8 divided by 8 is 1. That's what we wanted, 1m. 1m has the value of 0. 0 divided by 8. And again, we can get rid of that 1. So right here, we got a negative 1/2 that we're going to have to distribute into the parentheses. So negative 1/2 times these values. Again, you should be using a calculator to solve this. Negative 1/2 times the 4x would be a negative 2x. And then negative 1/2 times the positive 2 becomes a negative 1. This still equals negative 5. So this one's very easy to solve. It's a very easy looking one. So we're just going to add 1 to both sides. It's not too bad. We got this negative 2x over here, which equals 5. Negative 5 plus 1 becomes negative 4. So to solve, we'll divide both sides by the negative 2 to create a 1x. And we see that x equals 2. Again, you can use a calculator to solve that. Negative 4 divided by negative 2. So this one is a lot different looking because we got that distribution right here, but then it's added to 6. Now we don't distribute the 3 to the 6 because it's not 3 groups of 6. It's just 3 groups of 2x minus 4. So 3 times 2x would be the 6x. 3 times negative 4 is negative 12. So I got 6x minus 12 plus 6 equals, 12. So right here, and it's people have asked what we do. Some people would say you're going to subtract 6 from both sides and then add 12 to both sides. But we've seen this before. If we were to ignore this equals 12, then we just got an expression right here, which you guys have learned how to simplify these already from the previous unit. We would just combine negative 12 and then plus 6, which would leave us with negative 6. So that leaves me with 6x minus 6 equals 12. So again, this looks now a lot familiar. Very similar to the problems that we've already done. To solve it, we will add 6 to both sides. So that this zeroes out, and we got 6x equals 12 plus 6 is 18. And then we want a 1x, so we got to change the 6 into a 1 by dividing by 6. And we see that x equals 3.
Why'd you add 6?
Right there.
No, on the 12.
Now this next step that I'm going to show you guys is something that will guarantee that your answer is correct. However, the problem is that people think that it's so much extra work that it's not worth doing. But some people like to do it because it guarantees that they can get 100% on a test, which you guys can do, but this next step is kind of optional, so if you don't do it, you can still get the answer right, but you're kind of taking a chance that you're doing all the math correct. And some of you guys, well, you got some pretty good math skills, but just be careful because it's easy to make small mistakes which can throw your answer way off on these, okay? So, I'm really kind of showing you guys how to cheat, but it's legal cheating. It's encouraged. We encourage you to cheat this way. Now some people again still hate it because they prefer to cheat the old-fashioned way, which is bad. That's a bad thing, okay? So here's what we do, is let's go back to the original equation, 3 times the 2x minus 4. There we go. But right now we're saying that x is 3, so I'm going to replace the x with 3, and then I'm going to see if this is a true statement. Meaning I should end up with 12 equals 12. So to solve with these, now we're looking at order of operations. So I got 2 times 3 minus 4, there's multiplication. 6 minus 4 is 2. Now we got the rest of this stuff. So the 3, the plus 6, and this should equal 12. Now we're looking at order of operations again. 3 times 2 is 6. Plus 6, this should equal 12. 6 plus 6 does equal 12. So this gave us a true statement. Now that I've seen that that's a true statement, I can know that my answer that I had was correct. And if this were a test, I can know that I can get 100% on this. Not just because I checked, but I showed my work as well. All right, this one, so we went to Miss Jones and she was like, oh yeah, I got some stuff for you guys to evaluate. And as it turns out, we found a lot of mistakes in her students' work. And now you guys got to tell us what the mistakes were, which is good practice because these are all very, very common mistakes that students make, especially on a test. We don't want you to make the same mistakes, okay? We want you to make no mistakes so that you can get 100%. And of course, you should be checking these anyways. All right.
How come they're all the
So here's number 1. What the heck happened? Yeah?
I know.
Well, just tell us. What did they do wrong first? Yeah, they divided by 6 when this is actually negative 6. So we need to divide by negative 6 on both sides. 30 divided by negative 6 just makes this a negative 5. And we have the correct answer. But remember, this is a very common mistake. I see this on tests all the time. Unfortunately, I got to take points away because your method is correct. Just made a small error there. All right, here's number 2. So this is 3 divided by 4. The problem is that it's multiplied by the x, so it's kind of a double operation, right? Yeah. So what we could do is we could divide both sides by 3/4, like these. 12 divided by 3/4, you guys hopefully remember, we don't actually ever divide by fractions. We multiply by them, but then we flip the fraction, so 4/3. Hopefully you guys remember this. So I got 12 times 4/3. Again, I'm going to use a calculator to solve these. It's not going to be 9er. 12 times 4/3, 48 divided by 3, bam, 16. That would be my answer. Now this one would be pretty easy to check because we could just replace x with 16, plug that into a calculator, find that it's 12, and it checks off. All right. On this one again is a very common mistake because sometimes we forget what terms are. So we got an 8, a negative 5, and then that equal to this negative 37. The problem being is that this negative did not follow the 5c down right account. So when they divided by positive 5, yes, the technique is correct, but we're missing that negative right account. So that, as it turns out, is going to change that 9 into a positive 9. And that right there is our answer. Yay. All right, huge problem on these. So we got x plus 1 all over 3 equals 2. They tried to get rid of the 1 first. No, we got to get rid of the fraction. How do we get rid of the 3 that's in the denominator up in count? Yeah, times it by 3, but if I do it to one side, I should do it to both sides. See, now these 3's cancel out. And now we're left with x plus 1 equals a 6. That's a pretty easy equation to solve. What plus 1 is 6? 5. And we see that x is 5. Formally, we would show this as minus 1's radical. Bam, there it is. X is 5. We could check that. X plus 1, 5 plus 1 is 6. All over 3 does equal 2. It checks off. All right. Right here, 4x minus 3 equals 17. bam, they add 3 to both sides. Then they divide by, then they minus 4 and they get x equals 16. What the heck happened? Oh, thanks. We already knew that because we said that all of them have problems, right? I'm sorry.
Oh, I thought
Yes?
you only were talking about the first one that you did.
That is correct. They should have divided by 4 instead of subtracted 4. See, 4x minus 4, they're not even like terms. It doesn't affect the 4x. But when we divide it, it creates a 1x radical. And 20 divided by 4 is not 16. We'll replace that with 5. So now we got x equals a 5. Again, this one is so common that I expect to see it on the next test, even though we're showing you an example of what not to do. What the heck happened?
Wait, you're telling us to do something that's going to make us get it wrong?
I'm showing you something not to do. That's why the objective here is to correct the mistake.
He's showing us to not what.
Yes.
They didn't do the 3 times 4?
That is correct. They forgot to distribute the 3 to the 4 as well, which would have made that a minus 12 radical. Well, that, as it turns out, will change a lot of stuff radical. So let's go ahead and get rid of those 4s, because we're not actually going to add 4 now. Go back to that. What will we add instead? 12. So now we got 8 plus 12, which is not going to equal 12. That should equal 20. Now they did drop that 6x, that's okay. So 6x equals 20. Dividing by 6 on both sides. Again, that's not going to give us a 2. 20 over 6, we can simplify that. I'm going to divide both these by 2 each, because they're both even. 20 divided by 2 is 10. 6 divided by 2 is 3. And 10/3 is how we're going to keep this improper fraction. That'll do.
Is this just for you, or
All right.
for all the teachers in the school?
Yes. All right, this is another problem that I see often on the tests. So see how they've subtracted the 2x? Well, they subtracted 2x from both sides, but it's both sides of the same equation. So we wouldn't actually subtract 2x right there. So going back here, we would combine like terms, the 3x and the 2x, which would give us 5x. Then we would subtract 6, and this should equal 24. So solving, we'll add 6 to both sides. And we get 30 equals a 5x. And then to solve, we'll just divide both sides by a 5. And we see that x is 6. All right, what's wrong with this one? All right, now it may help to see this. See how we got minus this negative 2x? I would change that to a plus sign right there.
Oh.
Well, if I combine 5x and 2x, it's not going to be 3x. No, 5x's and 2x's, that should combine into 7x's like these. Now that's not going to change too much of the problem. We're just going to change these 3's down a count. Like these. So that becomes a 7x. We'll divide both sides by 7. And negative 9 divided by 7. We're just going to leave this as an improper fraction. So we'll say this is negative 9/7. And there's the actual answer. What about old Niner? This one again is a very, very common error. What the heck did they do?
Negative 2, the negative 2 would be 4 because 2 negatives are plus.
That's correct. That's going to change that to a plus sign radical, which means we would have to subtract 4, making this a 10 radical. So when we divide that by this negative 2, we should get negative 5 instead of negative 9. Very good. Very good. All right. Looking at this one, what did they do?
They did something wrong.
They added 9 and wait, no, they added 6x plus 3.
Very good. We can combine this 6x with this 3 because they're unlike terms. No, we can't do it. So, solving this correctly, we'd get 6x, but we can combine the 3 and the 4 to get a 7. So we will subtract 7 from both sides. That's a positive 7. So I'll subtract 7, and then we got 6x equals a 3. Dividing both sides by is 6. And we get x equals 1/2. So x is 1/2. All right, so to solve with these, right here, I got this upside down t right here. Now, if we can just compare 6 a's to some number, then we should be able to figure out how much each a is worth. So we can't have that minus 4 there. So how do we get rid of it? We need it to be 0, so yep, we're going to add 4 to both sides of the equation. So we'll drop this 6a, and now this equals negative 16 plus 4, which is negative 12. So now I can see that 6 a's have a value of negative 12. So to figure out how much each a is worth, I want to figure out how much a 1a is worth. So I'll change the 6 into a 1 by dividing both sides by 6. 6 divided by 6 is the 1. Negative 12 divided by 6 is negative 2. And yes, you should be using calculators to figure that stuff out because, well, that's what they're for. They're there to help you. All right, number 2, I don't really like this format. If you like it, that's okay, but I'm going to make this 7 equals 6 minus n over 7 like these. Well, if I can just have that negative n sevenths, then I need to get rid of the 6. So I'll make that a 0 by subtracting 6 from both sides. 7 minus 6 is a 1. This became a 0 pair right here, and we got negative n over 7. So this is where our inverse operations come in. That's n divided by 7. So to undo the division, we'll multiply both sides by the 7. See, these 7's cancel out. And I'm left with negative n equals 7 times 1 is 7. Well, I don't want a negative n, I want a positive n. So let's just take the opposites of both of these. So the opposite of negative n is n, and the opposite of 7 is negative 7. Bam, there it is. So right here, again, if we can get this negative 3x all by itself down right here, then we'll be in good shape. So I can't have that negative 10 with it. I want the x's by themselves, on their own side of the equal sign, and nothing else with it, just the x's, even if it's negative 3x's. So I got to get rid of that negative 10 by making it a 0. That's why we'll add 10. But if I do it to one side, I should do it to the other side. So this zeroes out, but negative 10 plus 10 over here also equals 0. Well, this is multiplication. So to undo that multiplication, we'll divide both sides by negative 3. And we see that x equals 0 divided by negative 3, bam, 0. Now 4 is a review because, well, we're going to need it for the other problems. This is distribution. And if we're distributing now, then we'll see distribution in the lesson later on with the equations. But these are just expressions, so we just need to simplify these. This one I'm actually going to change to, let's make that a plus 11 out of here. Not that it matters.
Do you have to do that?
I just want to show you guys this so that you can see what to do when you see an example like this on the homework and also the classwork. Well, that's 3 groups of 2x plus 1. So distribution, which is also the same as multiplication. 3 times 2x is 6x. Plus 3 times 1 is 3. And then we got this plus 11 right here, right? Well, to fully simplify this, I would have to combine the 3 and 11, giving us 14. So the final simplified expression, 6x plus 14. This one, Here we're distributing a negative 2 into the parentheses, so that's just multiplication. Negative 2 times 3x would be negative 6x's. And then negative 2 times 2 would be a negative 4. Alright, well I'm going to do C, where I will distribute this negative 4. Now the two terms inside the parentheses is 2x and then the negative 3, so we've got to keep that in mind as we do this. Negative 4 times 2x is negative 8x. And then we got negative 4 times negative 3, which would be a positive 12 right account. That is it. Alright, well, no more killing animals for now. Alright, so let's distribute the 2 into the parentheses. 2 times x would be 2x, and then 2 times 1 would be 2. This should equal negative 8 up in here. So to solve this, now this looks like an equation that we've been doing from the first lesson. So now we're just going to get rid of that plus 2 by subtracting 2 from both sides. And here's a mistake that we've been seeing, alright? Some people, negative 8 minus 2, bam, 6. If you get closer, you make that negative 6. It's still wrong. Here's where the calculators become so crucial. Is in your calculator, just type in negative 8 minus 2. You won't make these kind of mistakes, which if you do without a calculator happen so often, alright? I see this all the time on tests. I have to take the points away. It's unfortunate, okay? It's not negative 6. Negative 8 minus 2. It's negative 10. There we go. So this is a 0 right account. We'll drop the 2x. Now I got 2x equals negative 10. I'll just divide both sides by 2. Again, that's to make that a 1x. Now I got x equals, bam, negative 5. Thank you. No talking. While he does, it's very disrespectful. Thank you.
Can I talk?
Yeah, you're supposed to.
Oh. So, this. And that'd be negative 3x. Give me a sec. I knew what it was. Okay. Okay. Let's see. Give me a sec. Oh.
How'd you get that?
I don't know. Just kind of showed up.
You cheated?
No?
Well, how'd you get it then?
I don't know. Because that would be, you'd multiply x by negative 3, which would get you negative 6. And then you'd add that to 12, equaling 6.
All right, well.
I get it.
So confused.
Well, I mean, 2 is the answer, but let's see why. All right, let's solve this. So I'm going to put this 6 right account. And we can split this up again. I just want this negative 3x to be by itself. So let's make this negative 3x by itself. I don't want that plus 12. I want it to be plus 0. So to get rid of that 12, we'll subtract 12 from both sides. Now I got negative 3x equals negative 6. Again, you should be using your calculator to check this stuff. And then, in order to solve for x, what I will do is divide both sides by the negative 3, which leaves me with the 1x, that's a 1, and negative 6 divided by 3 is 2. Yes, the answer is 2, but we need to see a little bit more work than what was shown right there, okay? So, the answer is correct, just need a little bit more work. I will do this one. First, by distributing this negative 3 up in here. So negative 3 times 5x is negative 15x. Negative 3 times a negative of 1 becomes a positive 3. And this equals negative 12. So I want to get those negative 15x's by themselves, not with the plus 3, so I got to subtract 3 from both sides. So that will zero this thing out. Now I got negative 15x equals negative 12 minus 3, bam, still negative 15. So to finally solve with these, we'll divide both sides by negative 15. Now I'm dividing by negative 15 right account to make this a 1x. It just happens that the other side is the same. Negative 15 divided by negative 15 is 1. There it is. Number 8. Once again, we will distribute a negative value up in count. Negative 4 times 3 is negative 12. Negative 4 times negative 2m will give me a positive 8m out of count. Now this equals negative 12. So to figure out what the 8m is, I will add 12 to both sides. And now I got 8m's equals 0. Well, if I divide 0 amongst 8 peoples, then I can either go to Pro VU or just accept that we're 0. Number 9er, this is a fraction that we're going to be distributing, but not any fraction, not just any fraction. It is a negative fraction to distribute up in count. Again, hopefully this emphasizes the need, again, for a calculator. Negative 1/2 times the 4x is a negative 2x. Negative 1/2 times 2 is a negative 1. And this equals negative 5. So to solve, I will add 1 to both sides, leaving me with negative 2x's, which equals negative 4. Well, from here, I just need to divide both sides by negative 2. Again, the purpose of this is to make that a 1x. Now I got 1x equals negative 4 divided by negative 2 is 2. So 10 here caused some problems for some other folks, which is why we kind of changed that other problem where we was simplifying with distribution. So let's distribute the 3 up in here. 3 times 2x would be 6x. 3 times negative 4 is negative 12. And then we can't distribute it to the 6 because it's not saying we got 3 groups of 6. Well, right here, some people would say that we would maybe add 12 to both sides and then subtract 6 from both sides. And then, however, whatever. We can combine like terms right here. So I've got this negative 12 and 6, which I can combine to get a negative 6. Now, of course, we still have that 6x, and this equals 12. So in order to solve with these, we'll add 6 to both sides, so that we have just the x's. 6x, that zeroes out, equals 18. Now to solve, we'll divide both sides by 6. And x equals a 3. Alright, we're not done with this problem though. So here's what happens is, I'm going to show you guys a nice way to cheat, but it's legal cheating. In fact, I encourage you that you guys cheat this way, okay? There's a way to know on a test that your answers are correct on a test, okay? Now, a lot of you guys like the idea, but doing the extra work for some reason is just too much. Instead, you'd rather cheat the old-fashioned way. So, I encourage you to do this, but as much as I encourage you guys to do it, inevitably about 1 person per class will do it, okay? So, this is what we will do, is let's rewrite the original equation. So, now that we've got this, what we will do is, right now we're saying that x is 3. That's our answer. But to check to make sure that x is 3, I'm going to replace x with 3. And I just want to make sure that it's going to be a true statement. Alright. This is just order of operations, and we're just going to, again, make sure that this is a true statement. So, in the parentheses, I've got 2 times 3, which is 6. 6 minus 4 is 2. Now we still got the 3 and the plus 6, and this equals 12. So by order of operations would multiply these two, so we got 6 plus 6 equals 12. And what's 6 plus 6?
12.
Yeah, that's going to be 12. So does 12 equal 12?
Yes.
Yeah, that's true. Since this is true, we know that this is true as well. And we could know on a test, we could know that x is 3, and we could be done there, okay? Unfortunately, again, only about 1 of you will do it. All right, here at the top, we got with our good pal, Miss Jones, who said that her students made a lot of mistakes. So We put these on a worksheet and made you guys fix them and tell us what the heck they did wrong. But these are extremely common mistakes, which is unfortunate because even though we go over these, inevitably several people will make the same mistakes. Don't do it, okay? So, all right, so what did they do wrong on these?
They did everything right.
They did everything not right.
They did a positive
Yeah.
6 instead of a negative.
Yep.
It was going to be negative 5.
That is correct.
I just said that.
We should divide. Thank you, Juliet, for raising your hand, by the way, and waiting to be called on. So dividing both sides by -6 produces a -5 answer. And yes, they should have divided by -6 because -6t divided by 6 gives us a -t. Does not get rid of the negative there.
Explain mistake.
All right, number 2. Here they've taken 3/4 and multiplied it by 3/4. That's bad. What you would need to do here is divide it by 3/4. You divide the 12 by 3/4. Now yes, these cancel out, giving us 1x, and that's good. But it wouldn't be 9. 12 divided by 3/4 is not 9. Of course, we don't actually divide by fractions. We would end up multiplying this thing, multiplied by 4/3. And again, this is where a calculator becomes handy. When we multiply 12 times 4/3, we get 16. So right here, that first step is good. What's wrong with that second step then? This happens all the time on tests. This small little mistake will throw your answer off in a big way. Well, this term right here is a -5c, so that should be a -5c right there. Making these negatives as well. And so the answer wouldn't be -9, it'd be +9. All right, number 4. What they tried to do is get rid of that x plus 1, or just the +1 part of it. That's no good. We can't do that. We actually need to get rid of the 3 first, so none of this is really applicable. What we'll need to do is multiply both sides by 3, and what this does is those 3's cancel out. And then we're left with x plus 1 equals 2 times 3, which is 6. So to solve this one, we'd subtract 1 from both sides. And we're left with this x equals 5. On this one, the first step is good. What they've tried to do is subtract 4 right here to make this a 1x. But 4 minus 4 isn't even 1. And they're not even like terms. 4x minus 4, we can't solve that because they're not like terms. So what they should have done, let's get rid of this garbage. What they should have done is they should have divided by 4, which would have given us 5. See, 4 divided by 4 is 1. There we go. X is 5. Number 6. This one is also a very common mistake on a test. So they're distributing this 3. The problem is they've only distributed the 3 to the 2x. They need to distribute the 3 to the 4, making that a -12. So right here would have to add 12 instead of 4 to both sides, making this one a 20. We would divide by 6 there, so that's good. But in order to simplify this, we'd divide both these by 2. And we would get 10/3. So x is 10/3. Right here. This one also is common, just not as common as the other ones. So we got 3x plus 2x, so naturally you'd subtract 2x from both sides. No, that is not what you should do. What you should do is combine the like terms right here on one side of the equation. If you can on both, then that's fine too. So let's combine those. So combining the 3x with the 2x gives us 5x. Minus 6 equals 24. So adding 6 to both sides we get 5x equals 30. And then we'll divide both sides by 5. 5's cancel out into 1, giving us 1x equals 6. Alright, on number 8, on these types we just kind of forget how to simplify expressions, kind of like the last one. That's minus a negative right hand, so we're just going to make that a plus. Now when we combine the 5x and the 2x, we get a 7x. So the rest of this is good, except for this is a 7. Would divide both sides by 7, and the answer would be negative 9/7. There we go, negative 9/7. Right here. This is another more common mistake that we see on tests. So by distributing this negative 2 into the parentheses, we do get negative 2x, but this becomes a plus 4. So instead of adding 4 to both sides, we'd have to subtract it, making this a 10 right here. Negative 2, that's good. We do want to divide by negative 2 there, but that becomes negative 5. Alright, what the heck happened right here? Take a moment and look at that. What have they done wrongly? Yeah?
They combined it 6x plus 3, but 3 doesn't have an x.
That is correct. They have combined unlike terms. Very, very bad idea. So, the 6x is okay, but we can combine the 3 and the 4 to get a 7. So that's a positive 7. This again equals 10. So to solve this, we'll subtract 7 from both sides instead. And we got 6x equals a 3. So to solve for x, we'll divide both sides by 6. And we see that x equals, that should simplify down into 1/2. Bam.